Hello everyone. I'm glad to have Mr. David, our solution architect, today with me to discuss the Dorado V6 architecture and shed light on the key secret of Dorado V6 all-flash array architecture.
Thank you very much, Mr. Asher. So today we are discussing about the architecture of the Dorado, which is, by the way, is well designed, and it represents the latest technology and the leading word of the new technology. So first of all, we are discussing about the active symmetric architecture, about this overall hardware design.
So as we have the architecture of Dorado V6 in front of us, what are the key secrets here?
Well, good question actually. For this architecture, which we can see, the mainly design of this whole concept is about the full mesh, symmetric, active architecture.
You mean we have load balancing across all controllers. Here we have 8 controllers.
And also not only controllers, actually is layer by layer load balancing. Meaning that each one of the components should be interconnect to the other component also.
So the disk array enclosure has full connectivity over high-speed network, 100 gig RDMA with the controllers. So
Yes.
there is no LAN ownership, and all controllers can see the disk.
Exactly. They can discover the disk.
So what's the advantage of having this type of connectivity and the shared architecture, distributed architecture?
Well, the first key advantage for this, you avoid the single point of failure, meaning that every component should be have the full capacity of the reliability.
Okay.
In terms of active. Then this active, that's why just now I mentioned about the layer by layer, meaning you can see this architecture from down to the top. Every layer will be like a full redundancy with the active.
You mean it's a full shared architecture.
Yes.
So the front end board and the back end board, everything is shared. Because this one, it's connected everywhere.
Yes.
Okay? So the same port has the same connectivity with the 4 controllers.
Exactly.
Correct? This is for the front end and even for the back end.
Yes, you're right.
Okay? And this is, of course, will do for the city.
Yes, exactly.
And across the 2 enclosure, we have 100 speed connectivity.
Yes, for the interconnection between the two enclosure.
What about the cache? How many copies here we have for each data?
Well, see, for the cache, we have like a global cache. The cache will be shared into the overall
So
system.
the resources are shared.
Yes, resources are shared.
And we have 3 copies. Okay?
3 copies.
Across 2 different engines. So
Yes.
even we can tolerate failure of one engine.
Yes, and one more thing, when you have this shared cache, 2 things will be achieved. One is the best performance. So when we talk about the global cache, meaning that the cache will be shared into all the controllers.
And this will improve the performance. You
Yes.
mean now our performance is 20 million IOPS.
It's an amazing number.
Yeah, and by the way, the latency is just 0.1 millisecond.
Yes. Which is a very amazing numbers.
So from reliability perspective, how the 3 cache copies will improve the system?
Well, it's because of this shared cache. Then first of all, if you boost the cache performance, for sure, because it will leverage all the controllers' computing power. Secondly, about the reliability also, because the cache data will be also shared, then they will be avoid the single point of failure.
Okay, so we can tolerate 7 controllers out of 8 controller failure.
Because of this architecture, we call this architecture as the smart matrix, meaning that at the one time, at the same time that the 7 controllers fail, we can be a tolerance for this. And currently in the industry, no one can achieve this.
Okay, you just mentioned the computing power. We have computing power at the disk enclosure level. So it's a distributed architecture, distributed parallel machine.
True.
And the computing.
Yes.
So there is CPU here as well embedded and included in the disk array enclosure with memory. So some of the functions, okay, like deduplication and the compression will be implemented and the processing at the disk enclosure array.
That's why we call this disk enclosure to be a smart.
Yeah,
the meaning is the smart intelligent because we can share the load from the controller to this enclosure.
It's like offloading.
Offloading, exactly.
And we have end-to-end NVMe.
Yes, exactly.
Yeah, because you know the connectivity for the front end based on fiber channel iSCSI, okay, fiber channel up to 32 gigabit per second.
Sure.
And in the back end, we are supporting RDMA and ROCE.
Which is, by the way, 100G.
100G,
Yes.
which is very high speed. Any point you want to add, Mr. David?
I think for this architecture, which we call the latest architecture, we call Smart Matrix, it will boost the overall storage system performance as well as the reliability. Fantastic feature, I think.
Thank you very much.
Thank you for your time.
Thank you very much. Thanks, Mr.